let's get going on today's video. This one is about metals and their reactivity and their displacement reactions. So predicting whether reactions will happen or not, depending on where the metal sits in the reactivity series. This video is really about one rule, and the rule is that the most reactive metal will always end up as its positive ion. That's definitely the crucial part for this video today. What I've got here is the electronic configurations for sodium and for potassium. Now, from previous videos, hopefully you know that potassium is more reactive than sodium. Now, what that means is it means that it wants to form its positive ion more than sodium does. So that outer electron is more easily lost in potassium than it is in sodium. So if it wants to lose the outer electron more, that makes it more reactive. Let's check out an example. So here I've got sodium chloride reacting with potassium metal. Because the sodium chloride is an ionic compound and it's aqueous, that means that the ions are free to move. So actually, a better way of writing this is Na plus and Cl minus. So we look at the two metals, and currently I've got Na plus and I've got the K, the potassium, as a metal form. So let's pretend this reaction happens. If it happens, that means that I'm going to end up with KCl and Na. So really that KCl is K plus and Cl minus. So let's look at whether the more reactive metal ended up as the ion. In this case, we know the potassium is more reactive, and in this case it did end up as an ion. So definitely this reaction must happen. So the potassium is more reactive, so it will displace the sodium. Displace just means it will take the place of the sodium and become an ion. Let's check out a few more examples. So down the left-hand side here is your reactivity series, in case you haven't learnt that yet. And we're going to play a game of, does this reaction happen or not happen? So here I've written for you 3 reactions, some of which happen, because the most reactive metal does end up as the ion, and some of which don't happen, because the most reactive metal does not end up as an ion. Pause the video here, see if you can work out which ones happen, and which ones don't. So let's go through this. The calcium chloride reacts with sodium to become sodium chloride and calcium. So the metal that's the ion at the beginning is the calcium, the Ca2+. And if we look at calcium and sodium, calcium is below sodium. So the sodium should end up as the ion at the end, which it does, which is all good. So the sodium ends up as the ion, so everything is happy. This reaction can happen. In the second one, what you've got is iron oxide reacting with copper. So currently the iron is an ion and the copper is a metal. So let's look at iron and copper in the reactivity series. So iron is higher than copper, so at the end should end up as an ion. Unfortunately, in this reaction, the iron is not an ion at the end. The copper is the ion, which is not the way you want it to be. So this reaction doesn't happen because at the beginning, the iron is already iron 2+, and it's not going to give up that status to the copper, which is not more reactive. The bottom one, zinc is zinc 2+, and calcium is just calcium metal. So if we look at those in the reactivity series, we see that the calcium wants to be a calcium ion at the end. So let's check if the calcium ends up as an ion, and yes it does. The calcium ends up as calcium 2+, so this reaction can definitely happen too. That's all for today. This video predominantly relies around the fact that you know that the most reactive metal ends up as an ion. So you're looking for which one's most reactive and just checking that at the end it ends up as an ion.